What's up, guys? Welcome back. If you're still watching, because this is not a joke, all right? Truth is self-evident. When something is true, there will be evidence, okay? And when we're talking about our physical world, then there should be physical evidence, okay? One thing that science has deceived us into is not trusting our God-given senses. How many times have you heard somebody, a teacher, professor, anything like that, say something like, although it appears that such and such is happening, what's really happening is this, right? So, but what we have is experience, okay? So I want to talk again about some more holes in your scientific model real quick. And since obviously gravity is at the core of this lie, I'm going to go right to it, right? Because the point is that things still fall, right? You think they fall, right? Things appear to fall. Neil deGrasse Tyson did this is gravity, right? You know, he did that, and that's the proof of gravity. Okay, first thing that you need to understand is that you sink, you do not fall. Nothing falls. Everything sinks or rises. What we're dealing with here is density versus buoyancy, all right? The most abundant element in our air, we are living in an oxygen-rich atmosphere. That's what they tell us, right? Refer to your periodic table of elements, guys, and what you will remember is that they're separated in order of density, okay? Starting with hydrogen, right, which is number one, the lightest of all gases. We go gases, liquids, solids, right? Okay? Starting with the lightest is hydrogen. You put two hydrogen together and you get a helium, right? The second lightest of all compounds, right? Okay, moving on up, you get to number 8, which is oxygen, having an atomic number of 8. That represents its density, okay? What you need to understand is in chemistry, we do these experiments, okay? We've proven these things, and this is why I'm going over this, because if you remember forming a suspension ever, okay, in chemistry class, or for those of you who've ever done recreational chemistry, okay, what you'll remember is that you can separate things into a beaker, right, and they will suspend, right, okay? If you let them sit, they will, if it's not a solution, right, if you're dealing with like, you know, different like water versus oil type thing, right? It's going to form a suspension, we call this. It separates in order, okay? And what you will realize in our world, this is the exact thing that has happened. We have solids, we have liquids, and we have gases, and they have all formed a suspension in our environment, okay? Oxygen being the most abundant gas in our air, okay, in the air, means that everything lighter than oxygen does not sink. It rises. Because it is buoyant. Hydrogen balloons, helium balloons, anything less dense than oxygen will rise. Anything more dense than oxygen will sink until it meets number 9 or 10 or whatever, until it meets something more dense than itself, and then it will stop. Knowledge of this is demonstrated by none other than our Navy. Okay? Navy techs, submarine techs, you guys feel me on this because y'all can back me up. What we do know is it's a well-known phenomenon that gravity doesn't seem to exist underwater, right? That's the phenomenon, is that gravity doesn't exist underwater, because let's talk about submarines and how they achieve depth, okay? Because this is what we have here is my little horrible submarine drawing here, all right? But what we have here is this is representing of the ocean and different depths and layers in the ocean and the submarine. What the submarine doesn't have is any sort of a propulsion to push it down. It doesn't have a thrust down. It has a thrust forward. That's it. Now, yes, it has, you know, it's got the little rudders or whatever to help it dive. Yes, we understand that. Okay, but that's not going to cut it. If you've ever tried to swim down underwater, you know that you're not just going to get down there. Okay, you need something You need some tremendous force to overcome the density of water. Okay? And how the submarine does this, they achieve what's called a zero state. Okay? And that is they take on water. They become more dense. And literally, it's a mathematical equation of matching the density of the depth that the submarine wants to be in. If they want to be at 20,000 feet deep, all they need to know is how dense and what the pressure is at that depth. And then they can calculate how much water they need to take on in order to match that density. Once they have matched that density, as they match the density, the submarine is drawn. It suspends. Okay? That's how this works. That's how we do this in the real world. Okay? What we know is that water always finds its level. I'm a carpenter. I use water levels for a living. Okay? Water always finds its level, whether it's in a cup, or your bathtub, or the Atlantic Ocean. It always finds its level. And what we're living in is a giant suspension of solids, liquids, and gases. Just saying.